Question 1. We can see a scatter graph that shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. And what we have to do is work out, firstly, which one of the points is an outlier. Well, you can see pretty quickly that this is the one that doesn't fit the data, and we have to write down its coordinates. And we look as though we're 10 along here and 19, so 10, 19. For all the other points, write down the type of correlation. Well, I'm going to put the line of best fit on here first. Let's see if I can do that without messing it up. So something along these lines here, and that's a positive correlation. So let's write that down. So we have a positive correlation. The next part is, on the same day, in another British town, the maximum temperature was 16.4 degrees Celsius. Estimate the number of hours of sunshine. Well, we can use our line of best fit to help us here, and we will have some tolerance in the mark scheme. So be careful of the scale here. They seem to both go up in 0.2s for each little square. So this is 17 here, so 16.2, this is 16.4. So you'd read along, and you'd show this in the exam, but you'd use a ruler, obviously. And here I seem to be on 12, 12.2, 12.4, 12.6, I would say 12.8. So I'm going to write 12.8 hours. I think on the mark scheme it says you're allowed to have between 12 and 13. Now the last part is, a weatherman says temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason. Well, I would say definitely yes. And I'd say the reason is because as the majority of points for high temperature seem to happen when there are more hours of sunshine and it's a positive correlation, that would be my reason. So I'm just going to write that down. So just to recap, yes, and the majority of the points for higher temperature happen when there are more hours of sunshine. So just make sure that your sentence is convincing enough. Okay, right, let's move on. Question 2. We need to express 56 as the product of its prime factors. Well, let's have a look at some of the nice prime numbers, some of the early ones, 2, 3, 5, 7, 11. And the quick way of doing this is just to think of a times table that makes 56. Well, one that comes to mind is 7 times 8. 7 is prime, so we'll keep that one. And 8 we can say is 2 times 4. And then we can keep the 2 because that's prime along with the 7. And then we can ditch the 4 and say, well, that's 2 times 2 again. And look, we have all the prime factors. So we can write it with the smaller prime numbers first. 2 times 2 times 2. Cross them out when you've done them, times the 7. A shorter way of doing that, which is allowable, is 2 to the power 3 times 7. Question 3. We've got to work out 54.6 times 4.3. Now we can't use a calculator, so I'm going to use the method here, which is using estimation. And we can say 54 is roughly 50 and 4.3 is roughly 4. So we're looking for a number which is around the 200 mark in terms of magnitude, i.e. in terms of its size. So we can miss out the decimal points here. You can do your own preferred method of multiplication. Here's mine. So let's fill the grid in. And then we'll start with the smaller numbers because these are units. If you want to see a method of multiplication like this, then I've done some other videos on my channel. You can have a look at those. So we'll start with this number here. So that's 18, 24 and 12, that's 36 and 1, that's 37. 15 and 16, that's 31, and 3, that's 34, and 20 and 3, that's 23. But the answer wouldn't be 23,478. Let's think carefully. We're looking for a number around the size of 200, so in the 200s. Well, 234.78 would be the answer. So don't forget, however you do your method of multiplication is completely up to you, but the important thing is to know where to put the decimal point at the end, i.e. where the number makes sense, because we wanted 54.6 times 4.3. Question 4. The area of the square altogether is 10 centimetre squares, and we've got to show that x squared plus 6x equals 1. Well, we can use the diagram here for me to explain. This area here is going to be 9 centimetre squares because it's 3 by 3. This next area, this one here, will be 3 by x, which is 3x. This part here will be the same because it measures x by 3, or 3 by x, which is 3x. And then this last part here is square itself, which is x by x, which is x squared. So the total area that we've got on the diagram is x squared. 3x and 3x is 6x plus 9. And we're told that's equal to 10. So I think we're well on the way to show this now, because all we have to do is take away 9 from both sides, and we would have x squared plus 6x equals 1, which is the required result. Question 5. It says that the rectangular frame is made from 5 straight pieces of metal, and we know that the weight of the metal is 1.5 kilograms per metre. We've got to work out the total weight. Well, we can write in the parts that might help us. So if that bit was 5 metres, then that's going to be 5 metres, and this top part's going to be 12 metres as well. So we know that 4 parts have been used so far, and that's this top part, this bottom part here, and the 2 side parts. And so what we have so far is 12 and 12 and 5 and 5. So that's going to be 10, 11, 12, that's 14, 1, 2, that's 34. So we've got 34 metres so far. So the only part that we need to work out is this part here. So we're going to use Pythagoras to do that. Now, if it helps you in the exam, one thing you can do is you can draw a square on each of the other sides that you want, and you should know that Pythagoras' theorem said that the 2 smaller squares make the larger one, which I can't quite fit on the page. So we'd have 25 metre squares here for this smaller square. We'd have 12 by 12, which is 144 metre squares for this one, and we know if we added those two together, we'd get the area of this larger one here. Okay, that's essentially what Pythagoras is. So we've got 144 and 25, which is 169 metre squares. So we know that this whole area for the large square is 169. So if we square root 169, and we don't need a calculator for that, it's 13. Okay. One thing to know is that 5, 12, 13 is a Pythagorean triple. Okay, you can look that up later if you want. So we've got 13 to add on. So we've got 47 metres in total, and we know that we've got to then say that each metre is 1.5 kilograms from our original question. So we've just got to multiply 47 by 1.5. So I'm going to use a multiplication grid. You can do it however you want. So we've got 35, 27 and 3, that's 30. So we've got to use your common sense here. We know it's 47 times 1.5. So we know that it's roughly 47 times, say, 2. Okay, so 47 times 1 would be 47, 47 times 2 would be 94, so we're looking for a number between 47 and 94. Well, it's not 705, it must be 70.5. So to work out the total weight of the metal in the frame, it's 70.5 kilograms. Question 6. The equation of the line L1 is y equals 3x minus 2. Now, you should know that this is the gradient and this part here is the y-intercept. So this number here tells us how steep the line is. So it's going positively up by a gradient of 3. To look at the gradient of this one, because to show that the two lines are parallel, we want to show that they've got the same gradient, okay, because then they would be parallel to each other. So if we take the line 3y minus 9x plus 5 equals 0, and we rearrange it to get the y value, the y's on one side rather, what we can do is we can add 9x to both sides, and that would give us 3y plus 5 equals 9x. We could then take 5 from both sides, and that would give us 3y equals 9x minus 5. Now, we want it in the classic form y equals. Okay, so we just want one lot of y, not 3 lots. So we're going to divide both sides by 3. And that should give us y equals, well, 9x divided by 3 is just 3x, minus 5, that's got to be divided by 3 as well. Now, this intercept here is not important. What we're trying to show is that they have the same gradient, and they do. Now, for those that are at a really high level, you may have noticed I've said something which is not quite right. If this gradient was exactly the same, if this intercept was exactly the same as this intercept, then they would be the same straight line. And that wouldn't necessarily mean they were parallel. But it's not quite as convoluted as that. So we've shown that the gradients are the same, and that's all we needed to do. Question 7. It says that the mean mark for all the class is 60. So that means all the boys, that's 10 of them, plus all the girls, that's 20 of them. The mean mark, so we divide by how many there are, which is 30, and that would be 60. The mean mark for all the girls, by the way, if you're wondering what these 3 dots mean, it just saves me writing them all out. So the mean mark for the girls, all 20 of them, so we'd have to divide by 20, is 54. So this is quite good, because if you look at it this way, then if I say this is like equation A and this is like equation B, then I can find what this value is, because all I have to do is times both sides of this equation by 20. So I know the sum of all the girls' marks, all 20 of them, must be 20 times 54. Well, 2 times 54 is 108, and it's 10 times as much. So we know that that amount is 1080. So if I look at this part here, that's like me writing 1080 in its place. So I'll just neaten this up a little bit. And so if we write equation A, again, we would have all of the boys plus now 1080, all divided by 30, would be 60. And all I have to do to this equation now, this new one, with the value of 1080 put in the place of all the girls, I would be able to times both sides by 30, and that would give me 30 times 60. Well, 3 6s are 18, so that would be 1800. I just have to take 1080 from both sides. Let me try and move this a bit. So we'd have, from here, we'd have all of the boys' marks. And what we'd have here is, if I just get rid of this, we would have all the boys' marks would then be equal to 1800 minus 1080, which is 720. But in the question, it asked to find what the mean mark of the boys was. So we know that all their scores add up to 720, and we know there are 10 of them. So it's easy, it's just 720 divided by 10. So the mean mark for boys would be 72. So question 8, we have to write 7.97 times 10 to the minus 6 as an ordinary number. So if you think about it, if we have 10 to the power negative 6, that means divide whatever number is in front. So say we take the number 3, a nice easy number. It means divide that number 3 by 10 6 times. So if we were to have 3 times 10 to the power 6, that would mean you take the number 3 and you times by 10 6 times. So we know they both had a times sign here, but it's actually this sign here that tells you whether to times or divide by. So in this case, we've got 7.97, and we've been asked to divide by 10 6 times. So a nice way of doing this is to go divide by 10 once, twice, 3 times, 4 times, 5 times, 6 times. So the decimal point would be here. And then you can put all these zeros in here nicely. Let me just get rid of this. So that would be our answer, 0.000000797. So if you're still not sure, I can do a little bit more. If you are, you can just press the forward key and it will skip forwards. So let's do one more example here because a lot of students do find this difficult. So let's try and have 5.2 times 10 to the 4. Well, you take the number 5.2, and in this case it's a positive 4 here, not a negative, so we're timesing by 10 4 times. So you'd have times by 10 once, twice, 3 times, 4 times, so the decimal point would end up here, and the answer would be, well, 52000. You don't need to write 0.0 at the end, so the answer would just be 52,000. However, if it was 5.2 times 10 to the minus 4, well, I think you know what to do now. You divide by 10 4 times because it's a negative sign here. So 1, 2, 3, 4. And the answer would be 0.00052. So there's a lot of maths behind why something to the power negative number means divide, but I won't go into that now, but there's a little bit of an explanation for you. So part B says we've got to work out the value now of 2.52 times 10 to the 5 divided by, and I'd write it this way, 4 times 10 to the minus 3. Well, we don't have a calculator in this particular part of the exam, so Let's do the indices first. So we have a common base here. Basically, they're both 10 to the power of something. So we know when we divide, you should know that when we divide, we take the powers away. So this part would stay the same. You could almost split it up into two different parts. So we'd have 10 to the 5, take away this power, and be careful, it's already negative. So we're taking away a negative, which is adding. So we'd have 2.52 over 4 times 10 to the, well, this would be 8. Now we can work this part out. So if we just halve 2.52, we'd get 1.26, and if we halve it again, we'd get 0.63. So that's 2.52 divided by 4, and you can do that in many different ways. It's up to you how you do it without a calculator. So I know I've got 0.63 times 10 to the 8, but we should know a standard form. This number has to be between 1 and 10, can't be 10. And so therefore we can say, well, it's 0.63 times 10 to the 7, because 10 to the 1 times 10 to the 7 gives us 10 to the 8. And then this helps us to find our final answer. So what we can do is we can say, okay, 0.63 times 10 is 6.3, and we've just got our 10 to the 7 left. So that's the answer that I would give.
Question 9. Jules buys a washing machine. It says that 20% VAT is added to the price of the washing machine, and then Jules had to pay a total of 600. So we know that 600 was paid in the end. We can have our little picture of a washing machine here, and we know that 20% VAT was added. So we should know that if we multiply it by 1.2, and the reasoning behind this is that's the same as 1 plus 0.2. So if we had to multiply this out, we'd get the washing machine's price to start with, i.e. times by 1, and then we'd add the 20% on all in one go. So a good thing to do would be to write something like an equation like this. So we want to find the price of the washing machine with no VAT added, i.e. what it was to begin with. So if we just write our equation out again, then it's quite simple to find this, because all we've got to do is divide both sides by 1.2. So we'd have the washing machine would be 600 divided by 1.2. Now don't worry about that too much, because it seems a bit complicated. One thing you can do is you can say to yourself, if you have something like 600 divided by 1.2, just write it as 12. You know what the question was, so you can halve top and bottom. Now you should know that 6 is into 300 is 50. If you don't, you can halve again. And 3 is into 150 is also 50. So you could say the answer was 50, but then check very carefully to see whether it is, because we want to do 600 divided by 1.2. So if you use your powers of estimation, then that's roughly 600 divided by 1, which is around the 600 mark. Now 50 would not be around the 600 mark, would it? So you should be able to see that using our estimation, the answer would have to be 500. Now that's one way of looking at it. An alternative is, if you don't like that, you can do 600 divided by 1.2. You can times top and bottom by 10, because that's the same as timesing everything by 1. And you'd have 6,000 divided by 12. Then you can halve top and bottom and do it again. And this would also give you the answer 500. So £500 would be the answer.
Question 10. We want to show that this expression here, x plus 1 multiplied by x plus 2 multiplied by x plus 3, can be written in this form. Well, let's have a look. Now these three brackets are multiplying each other, so it doesn't matter which order we do them in, because multiplication, the order does not matter. So we can just do these two multiply by each other first. So we can just set up a multiplication grid, if that helps. You don't have to put these plus signs in here. So you would have x squared, 1 times x is x, 2 times x is 2x, 2 times 1 is 2, and that would give us, and they're all positive. And then we've just got to multiply the amount we've just found by the remaining bracket, x plus 3, and again you can do this by this multiplication way. I've always done this. Not many people do it this way. You might have your own ways of doing it. So let's have a look. X times x squared would give us x cubed. X times 3x is 3x squared, and x times 2 is 2x. And then we've got positive 3 lots of x squared, positive 3 lots of 3x, so that will be 9x, and then positive 3 lots of positive 2, which is just 6. So what have we got altogether? Well, we've got 6 here, which is positive. 9x and 2x is 11x. 3x squared and 3x squared more makes 6x squared. And then we've got x cubed. So this is indeed the form ax cubed plus bx squared plus cx plus d, where a is 1 in this case, b is 6, c is 11, and d is 6. Question 11. The graph is shown on the grid. The first thing we've got to do is write down the coordinates of the turning point of the graph. Well, the turning point in this case is the minimum part, which is here. So the coordinate looks to me to be 1 along and 3 down. So we're going to go 1, -3. Write down the estimates for the roots of f of x equals 0. Well, if we want f of x equal to 0, then that's the same as finding the x ordinates, or the points on the x-axis where the graph intersects. So we can look carefully, and I can just expand this a little bit so we can see more clearly. Well, I can see one here, and it's only an estimate. So if this is 0.5, 0.6, 0.7, 0.8, we'd go negative 0.75 would be a good estimate. And for this one, this is 2.5, 2.6, 2.7, 2.8. So we go 2.75 in this case. Now I paused then for a second because I just wanted to check what the scale was going up in, because you don't want to get that wrong. So these are 0.1, 0.2, 0.3, 0.4, yeah, 0.5. So they're going up in 0.1s. So they would be my estimates. So if we go back to the question here, we can just write that in. So we can say x equals, well, we won't say x equals. We'll say x is 2.75, because they're estimates, don't forget, and x is negative 0.75. Then part C says, use the graph to find an estimate for f takes on the value 1.5. So hopefully you're aware of what that means, but I'll just run over it quickly. If we wanted f of x, that gives us y, i.e. y-axis being our outcome here, or our range.
that means for every x value we put in, we get a y value coming out. So, for example, if I put 1 in on the x-axis, then we've already worked this out, that's our minimum point, and -3 would come out. So what the question's asking you is for part C is, and we'll put that in, is what's f of 1.5? Now this is going to be an estimate because we're using our graph. So if we go along to 1.5, which is here, let's read down, and you'd use your ruler here, and to get all the marks I would suggest you'd have to do that in the exam, and then just read across, and then I can zoom in here because it helps me. So we've got -2. Now on the y-axis it's not going up in 0.1s, it's going in 0.2s, so -2.2, -2.4, -2.6, -2.8 would be my estimate to f takes on 1.5, or f of 1.5. So we said -2.8, didn't we? So we'd go -2.8. Okay, so the key word here is estimate, okay, or estimate. So don't worry too much, but show the examiner on your graph that you know what you're doing by using your ruler. Question 12, part A. Find the value of 81 to the power -1/2. Well, that's the same as 81 to the power 1/2 to the power -1. Because a to the b c is the same as a to the b to the power c. Okay, so check your rules of indices there. Now, if you have something to the power 1/2, that's the same as square root. So that's the same as the square root of 81 to the power -1. Well, the square root of 81, that's just 9, and that leaves us 9 to the power -1. And knowing your rules of indices, something to the power -1 is the reciprocal. So there's our answer, 1/9. Part B, we've got 64 over 125 to the power 2/3. Well, I would definitely look at this as being 64 125ths, and I would say look at that to the power 1/3, which is the third root, and then square. Because don't forget, if we have a to the b to the power c, that's just a to the bc. Okay, you multiply the indices together. So it's like having two lots of 1/3. I'll just highlight that for you. That's like having two lots of 1/3, which is 2/3. Okay? Well, if we third root 64, that means something times something times something is 64. Well, that's 4. And then the third root of 125 is 5. So that's all of this part done. That's the third root of 64 125ths. And I put a bracket, don't forget, around all of that because it was all to the power 1/3. And all I need to do now is square, and that's exactly the same as saying 4/5 times by itself. And that's going to give us 16 25ths. So there's our answer to part B. Question 13. Here we're given a table of values relating x and y, and we're told that y is inversely proportional, so inversely proportional to the square of x. So that's 1 over x squared. Now, we're given some values, and all we've got to do is find the equation for y in terms of x. So we know that y is proportional to 1 over x squared, or the inversely proportional to the square of x. So that means that it has this kind of shape. So if we draw our y-axis and our x-axis, we know then that when x is very large in here, that y would be very small. Okay, so we know that if x was very large, say right up here, a large number, we know that y is very small. But then when x gets very small, we know that 1 over something very small is quite large. But if that thing, say 0.1, for example, 0.1 squared is 0.001. And 1 divided by 1,000th is 1,000. So we know that as x gets smaller and smaller and smaller, especially when x is between 0 and 1, we have this kind of situation happening here. Now there's a whole family of curves that this could be, and we just want to find one of them that suits this table of values. So you don't have to go into detail with all of this, okay? So don't worry too much. Well, that means that y is going to be equal to some constant over x squared, because as that constant changes, it will give us all these types of graph here, and we only need one of them. So what we can do is we can put in some values from our table. So let's choose some easy ones to start with. This is a nice one. When x is 1, y is 9. So if we have y equals k over x squared, if x is 1 and y is 9, we can substitute those in. And that means that k is equal to 9. Now, it doesn't matter which ones we chose, we'd still get the same answer. So if you don't believe me, we'll try this one. So let's say when x is 3 and y is 1. Well, if we put it into the same equation here, we'd have 1 equals k over 3 squared. So 1 would be k divided by 9, so k would be 9. But the idea is to probably steer clear of these ones here and maybe use the nice integer values. So what I did was, don't forget, I chose x is 1 and y is 9 first, and that gave me k was 9, so I know that y equals 9 over x squared. It then says in the question, find the positive value of x when y is 16. Well, let's have a look. So if y is 16, that means we're going to have 16 equals 9 over x squared. A nice little trick here is that 16 is 16 whole ones. So if we invert both sides, that's the same as doing this, both sides to the power negative 1. Then we'd have x squared over 9. Then we can times both sides by 9, and that would give us x squared is 9/16. So what that means is something times something is 9/16. Well, you can see that it's 3/4. Because if we did x times x, we'd get 3/4 times 3/4, which would be 9/16. When it says the positive value, there is this possibility, negative 3/4 times negative 3/4, that would also give a positive 9/16. So x is going to be 3/4. So I suggest in this question is that what you do is maybe try it again, but maybe try and find the value of k using some more difficult values. You should get the same answer and see how you get on.
Question 14. White shapes and black shapes are used in a game. Some of the shapes are circles, all of the other shapes are squares. It says the ratio of the number of white shapes to the number of black shapes is 3:7. The ratio of the number of white circles
the number of white squares is 4 to 5, and black circles to black squares is 2 to 5. So we have to work out what fraction of all of the shapes are circles. Well, I try and look at this as parts here. I have 3 parts and 7 parts, so I know that all the shapes are represented by 10 equal parts. Okay, so that's really important. We know that we want to look at what fraction of all the shapes are circles. Let's start with the white ones. 4 out of a total of 9 parts here, so 4/9 of those are white circles, but how many of the shapes are white in total? Well, 3 out of a total of these 10, 3/10. So 4/9 of 3/10 is what fraction are white circles so far. We want to now look at black circles. Okay, so 2 out of 7 are black circles compared to black squares, but if we look at the proportion of black shapes, well, that's 7 for every 10. So this was white circles, this is black circles. So all we need to now look at is, what do these work out to be? And once we've worked them out, if we add these together, that will give us the fraction overall of how many of the shapes are circles. So let's look in detail at how to cancel that down. We don't have a calculator for this paper, so we need to be careful. So 3/9 is 1/3, 4/10 is 2/5. 7/7 is 1/2, 2/10 is 1/5. So we have 2/15 for white circles and 1/5 for black circles. If we times top and bottom here by 3 to get the denominators the same, then we have 2/15 plus 3/15 gives 5/15, which you can have as your answer. I don't think it says in its lowest form. Let's have a look. No. So you could write 5/15, but let's just cancel it down because we know what that is. That's going to be 1/3 for circles in total. Question 15. A cone has a volume of 98 centimetre cubes, and we're given the volume formula here, and the radius of the cone is 5.13 centimetres. We have to work out an estimate, i.e. using numbers we can use simply in our heads, for the height of the cone. Well, let's write the formula down. V equals 1/3 of pi r squared h, which is the same as just pi r squared h over 3. Now, let's put in the numbers that we know. We know V is 98 here, so we're going to say that's roughly 100, because we're doing an estimate, don't forget. Pi, we can estimate to be 3. The radius, we can just keep as 5, so we want 5 squared, times the height that we want to find as an estimate, all over the 3 that's given in our formula, so we don't need to change that. Now this would cancel nicely here, and what we'd be left with is this would turn to 5 squared, which is 25, so that would be 25 lots of h is 100. Well, 25 lots of 4 is 100, so h is roughly going to be 4, because we can divide both sides here by 25. And I'll just show that. And that would give us h is around about 4 centimetres. And that would be, don't forget, an estimate. Now the next part of the question says, John uses a calculator now to work out the height of the cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Give reasons for your answer. Right, so we don't have a calculator in this exam. So what I would do is I would probably rearrange the formula. So we started off with V is pi r squared h over 3. So if we multiply both sides by 3 first, we'd have 3v equals pi r squared h. This is all multiplied, so we can divide both sides by that. I'll just put this step down so you can see what I'm doing. I'm dividing both sides by pi r squared. And that would give us h equals 3v over pi r squared. Well, how does that help us work out the answer to the question? You know, will your estimate be more than John's answer or less? Well, he uses a calculator to work out the cone's height to 2 decimal places, and we've got to remember the figures that we used here. So 98 centimetre cubes for the volume and 5.13 centimetres for the radius. But when we did our estimate, we said that the volume was roughly 100 centimetre cubes, and we said that our radius was 5 each time because we had to square it, don't forget. So what we actually did is we made the numerator increase and we made our denominator decrease. So I like to look at it as cakes and people. We basically increase the amount of cake and we decrease the amount of people sharing that cake. So the answer is going to be more. And I'll just repeat, that's because the number in the numerator has gone up in our estimation, and the numbers in the denominator have gone down in our estimation. So that's the reason behind it. And I've just done a little written explanation here to finish that question off for you. Question 16. It says that n is an integer greater than 1, so a whole number greater than 1, and we've got to prove that this expression is always an even number. So let's have a look. Well, let's try expanding this part and see what happens. I'm going to use square brackets here because n minus 2 multiplied by n minus 2 gives us the n squared here, minus 2n more, and then minus times the minus 2 times the minus 2 is positive 4. So that gives us n squared minus 4n plus 4. And so we'd have n squared minus 2 minus n squared plus 4n minus 4. These cancel out. And we're just left with 4n minus 2 minus 4 more is minus 6. Now what does this mean? Well, this means 4 lots of n minus 6. Now I can tell that's always going to be even because this is a nice little thing to do. If you take out 2 as a factor, you're going to get 2n minus 3. So if n is an integer greater than 1, say 2, 3, 4, 5, 6 and so on, then if we substitute those values for n, we'll have to multiply them by 2, take away 3. Yeah, that's fine. And that can be a whole set of numbers. But the most important thing is, after we've worked out what this is, we then have to double it. And if we double something, it's always going to be even, because it's a multiple of 2. Okay, so hence even. So with all these types of questions, if you're trying to prove something is even, look out for that. Question 17. It says there are 9 counters in the bag, 7 are green, 2 are blue, and Ria takes at random 2 counters from the bag. Work out the probability that she takes 1 counter of each colour. So that would either be green first, then blue, or blue first, then green. Green, green, and blue, blue would not be acceptable. So we can draw a tree here to help. So this would be our first choice and our second choice. Our first choice could have been a green, or it could have been a blue. And based on that first choice, our second choice could have been a green followed by a green followed by a blue. Or we could have had blue first, then green, or blue first, then blue. But we want the outcomes where the colours are different. So the probability for the first choice of picking a green, well, that would be 7 in 9. So the probability of picking a blue would be 2 in 9. Now, as the counters are not replaced, our second time for a blue, I'm not going to do the green, our second time for the blue, well, they would still be 2 counters that were blue in there, but it would be out of 8 this time. And if we'd chosen the blue first, here, then how many greens would there have been left? Well, there would have been 7 still. So 7 out of, and don't forget there'd only be 8 left. So the probability of getting to this juncture on the probability tree would be green then blue, so it would be 7/9 times 2/8, and to get to this juncture it would be 2/9 times 7/8. Now I'm not going to cancel this down, and the reason why, because it's going to be out of 72 possible choices, and that tells us more about the situation here. So we've got 14 and 14, so in total we would have 28 out of 72 chances, or 28 70-seconds. If you want to cancel that down, then you could. I wouldn't, to be honest. So you could have 14 over 36, or 7 out of 18. Question 18. We're given that ABCD is a rhombus, and we're given the coordinates of A are 5, 11, and we're given the equation of the diagonal DB, so this line just goes on forever through DB, is y equals a half x plus 6. Find an equation for the diagonal A through to C. Okay, so we want this line here. Now, if you don't know the properties of a rhombus, then I'm afraid this is going to be really tough. The properties of a rhombus is that has all the sides are the same. It's like a squash square, and basically this is parallel to this here, and this one is parallel to this one. But the key thing here is that they intersect at right angles. So AC and BD are perpendicular to each other. So that should ring a bell, that if we know that the gradient of DB, so the gradient of DB from here is given as a half, we should know therefore that the gradient of AC is -2. Because the little thing here from your lessons you should know is that two perpendicular gradients, their product is always -1. So if you know one of them and you want to find the other, well, in this case you can times both sides by 2 here, and you get x is -2, i.e. the gradient of the other line is -2. So we know that the gradient of the line AC that goes through A and C is -2. So we know that it's y equals -2x plus something. But luckily for us, we also know that it goes through the point 511. So if I'm just going to write this up here, because I've got a bit more room. So we knew this. We knew that it also goes through the point 511. So when x is 5, y is 11. And that will help us find c. So c is going to be 21. So we now have our final answer is the equation of the diagonal AC, or the line that goes through it, would be negative 2x plus 21. Question 19. It says that OABC is a parallelogram, and we're given that OA is A and OC is C. I can't do my vectors in bold, so I'm just going to underline these. And so it says x is the midpoint of the line AC. So if I want to go from A to C as a vector, it's saying the midpoint of this is x. OCD is a straight line, so there'll be a point D somewhere on here, such that the ratio of OC to CD is k to 1, and we've got to find the value of k, and we're given what xd actually is. So let's draw in xd. So if we're given xd equals 3c minus a half a, we should be able to find xc, because we should also know what AC is. That's quite easy. So to get from A to C, if you think about it as a journey, to get from here to here is the same as going minus A plus C, or just C minus A. And we therefore know that the vector x to c, so x to c here, must be half of that journey. So we know what xd is, and we know what xc is, so we can find cd. So c to d should be, well, it should be minus cx, sorry, it should be c to x, which is minus xc, plus xd. So I'll do that once more. So c to d should be cx plus xd. And we know that cx is minus xc, so we should have changed the signs in this, so we'd have a half a minus a half c plus xd that we've already got. So we're getting there. So from here, if I just neaten this up, so we've got a half a minus a half a, which is 0, and then we've got 3c minus a half c. Well, 3 minus a half, that's 2.5, or 5 over 2c. So we know that OC is given in the question, and we also now have CD. So we can think about this. If this was C here, and we've just found this as 5 over 2c, we want the ratio k to 1. So we've kind of got one of these and 2.5 of these. So I'll just create a little bit more space for you so you can see. That means we've got 1 to the ratio of 5 over 2, but the question wants this to be 1. So if we times both sides by 2 and divide both sides by 5, then k is equal to 2/5.
Question 20. We've got to solve this pair of simultaneous equations. Well, this first one here is a circle of radius 5, which I won't go into now. And this one here is a straight line. Now, I'll explain that a little bit, because if I get that into the form y equals mx plus c by adding 3x to both sides, then I'll have 3x plus 13. So we can see we have a straight line and a circle, and in rough terms they'll probably intersect twice. It's rare that there'll be a tangential situation going on, so we're looking for probably two solutions. So if we just rewrite these on top of each other, call that equation A, and call this one equation B, then what we can see here is we have x squared plus y squared is 25. Well, we have this equation here in terms of y, so we can put sub in A. So wherever we see a y, we just substitute 3x plus 13. So we'd have x squared plus, well, y squared would be 3x plus 13 all squared equals 25. So if we just move this a little bit, and let's try and solve this equation. So we'd have x squared plus, well, if you want to square this bracket, then we can do a little grid if you want. And then we'd have 9x squared, 39x, another 39x, and then 13 13s are 169. So we'd have 9x squared, 78x, plus 169 equals 25. So what I'm going to do now is I'm going to collect all the terms together and get everything on the left hand side. So I'm going to have x squared plus 9x squared is 10x squared plus 78x, and then I'm going to take 25 from both sides here, and that will give me plus 144 equals 0. Now the nice thing about this is even, even and even, so I can halve everything and have 5x squared plus 39x plus 72 equals 0. And now I can probably factorize that. So it looks very difficult, but let's give it a try. And so we'd have 1 and 5 here, factors of 5. You might do this a different way, of course. Factors of 72. Well, I will go with 72 and 1, 36 and 2, 18 and 4. So let's have a look. We want to try and get the number 39 if we can. So 9 and 8. So I think I've seen it. Again, this takes a lot of experience, so take your time on learning how to factorize. Just looking closely at this, I can see that this would cause some students some difficulties, because you could say, for example, that to try and get the number 39, you're close by saying 8 5s are 40, but then you've got 9 times 1, which you can add and get 49. But I think we need some more factors of 72, and I can see you could have 3 times 24. And then the nice thing about 3 and 24 is that if I did 3 times 5, that's 15, and then 24 times 1, that's 24. And if I add those, I will get 39. So let's see how that works. Well, we'd have, these are the coefficients of x, so I'd have a 5x and a 1x, or just x, and then I'd have 3 and 24. Now we've got to be careful, because we said that the 3 goes with the 5, like we had here.
okay, 3 with the 5. So if the 5x is already here, then the 3 has to go here, and that just leaves room for the 24 here. So if you multiply these out, we're going to get 5x squared, 24x like we wanted, 15x, and then 72. And that gives us 5x squared plus 39x plus 72, which is just what we wanted. So our factorised answer would be 5x plus 24, lots of x plus 3. And don't forget equal 0, because we had equal to 0 here. So what that means is we should now be able to find the solutions to this equation here by putting both brackets equal to 0. So we'd have 5x plus 24 is 0, which means x would be minus 24 over 5. And then this bracket is easy, that would just be x is negative 3. But don't forget, the straight line will now tell us how to get the y values, and we rearrange that to be y equals 3x plus 13. So if I bring that into play here, so I'll just write that out, y equals 3x plus 13. Then it is nice because let's do the easy one first. If x is minus 3, then y is 3 lots of minus 3 plus 13, which is minus 9 plus 13, which is 4. So x is minus 3, y is 4, is one cutting point, i.e. where the circle cut the straight line. And the other one's a little bit more tricky. So if we say y is 3 lots of negative 24 fifths plus 13, then we're going to have 3 lots of negative 24 is negative 72 over 5, plus, get this into fifths, so how many fifths are there in 13? Well, 65 fifths. And then negative 72, add 65, well that will be negative 7 fifths. So our other solution is x is minus 24 fifths, y is minus 7 fifths. So reasonably difficult question there. So just be very careful on how you factorise. There are many ways of doing this question, of course, but this is my easiest route through the problem.
Question 21. We're given a quadrilateral ABCD. We're given that AB is the same as CD and that angle ABC is the same as angle BCD, and the angles are drawn in. We've got to prove that AC is equal to BD. Well, what I'm going to do is I'm going to draw two different triangles here. A, B, C, and I'm going to join those up to give AC. I'm going to put this angle in here and this length that's given. I'm then going to look in a triangle BCD. I'll do that a bit better. It's not much better, but it will do. And we'll have BCD here. Now, the first thing that you can state from this proof is the obvious, and that is that angle ABC is the same as angle BCD. I know that's given, but in our diagram we've got to show that relationship, okay? Also, the second thing we've got to state is that AB equals CD, even though that was given, we're just demonstrating that from our diagram. Now, the nice thing that we can show in this case is that BC is common to both triangles, so we're going to write that. BC is common to both triangles.
And what we can conclude from that is if you know how to do your proofs, we have to state a situation here that triangle ABC is congruent to triangle DCB, and the reason is side, angle, side, and in this case we have a side, an angle and a side, an angle and a side that correspond to each other, and from that therefore AC equals BD. So I think these are probably some of the toughest questions on the GCSE syllabus. I always struggled with these at school, I have to say, myself, so maybe I've not explained this the best way. There might be other places where you can see better explanations. There are some good YouTube channels out there that can go into these topics and spend a bit more time explaining, but your teacher's probably doing that for you anyway. Okay, so good luck with these types of question anyway. Question 22. Probably one of the most difficult questions I've had to explain on a GCSE paper. Not because it's like amazingly difficult, although it is difficult, it's just a lot to show. So let's get going. We're given that AB is X, BC is X, and that ABC is 30 degrees. So I'm going to make a triangle in here called triangle ABC. Okay, ABC. And I'm going to use the cosine rule in that triangle, and I'm going to assume you know how to use the cosine rule, okay? So we'd have x squared plus x squared would normally be equal to AC squared if it was a right-angled triangle, but it's not, so we've got to take away 2 times x cos 30. Also, new in the GCSE to know, you have to know cos 30 is root 3 over 2. So cos 30 is the same as sine 60, which is root 3 over 2. So I can simplify this a little bit. So I've got 2x squared minus 2x squared cos 30 root 3 over 2. These cancel here, and that leaves me AC squared is 2x squared minus x squared root 3. So I'm definitely going to underline that, and I shall come back to that. The next part of the question says that BP and BQ are both 10. So that leaves me this triangle now, which is triangle PBQ. And don't forget, PBQ is the angle that's involved in the proving of the final answer. So that's going to be significant. So we're going to call this angle now the one we want to find, and I'm going to just call it theta. So in triangle PBQ, the green triangle, we're going to have cos theta equals 10 squared plus 10 squared minus PQ squared all over 2 times 10 times 10. It's just another way of using the cosine rule with the angle given as opposed to the length. So I'm letting theta obviously equal PBQ, that angle, okay, just so you know. So that's going to be 100 plus 100 minus PQ squared over 200. So cos theta is going to be 200 minus PQ squared over 200. Now, we're lucky because in this diagram that we've got, AC and PQ are on the same horizontal and they're the same length. So we can use that fact. So if we just look at this here, we can write it as cos PBQ now is equal to 1 minus PQ squared over 200. But PQ squared must be the same as AC squared because PQ and AC are the same. So let's substitute PQ squared for AC squared. And be careful of the sign here. We've got cos PBQ equals 1 minus, I'll put a bracket round so we don't make a mistake. PQ squared is AC squared, so that's 2x squared minus x squared root 3. Now I did assume that AC equals PQ, but because P is the point on AF and Q is the point on CD, that BP and BQ are both 10, they're going to be on the same level, okay? And if they're both on the line AF, i.e. P is on AF and Q is on CD, then they're going to be at the same level, which means they are going to be parallel to each other. So AC and PQ are also parallel. So let's just see if we've got the answer now. So we're going to have cos of PBQ is going to be equal to 1. Now minus, I'm going to just have a look carefully here. I'm going to take out the x squared here. And that's going to give me 2 inside, and then I'm going to have a minus root 3 here, all over 200. And I think I'm nearly there because I've definitely got this 2 minus root 3 in here. The only difference is they've just put the x squared at the end here. So if you're going to prove it, you've got to write it all, I guess. So from what we have here, we've got cos of PBQ equals 1 minus, now, don't want to do that, do I? 1 minus 2 minus root 3 x squared over 200. So, quite a difficult question to explain, but hopefully you understood all the steps involved. So good luck with trying that one. Try it in a few days' time or something and see whether you can do it from scratch.